Hey guys, a very warm welcome to my YouTube channel. This channel is called On Tech Field, and I've already introduced my channel on the short introductory video on my channel, which you can check out. So right now my voice quality isn't that good because I don't have a mic right now. I don't have a microphone, which I am planning to buy quite soon. So that will be fixed very soon. And I'm quite awkward because this is my first time experience of creating and uploading a video on YouTube. I had done this before once or twice when I was in 6th standard, I guess, but those times were different. Right now I am more formally creating a video on YouTube. So while I write on the board, you might not be able to see my face, which you wouldn't even want to. So I feel that's okay. So let us begin with our topic. So this topic is calculus. Now what's calculus? Calculus is a branch of mathematics जो कि खोजी गई थी कुछ लोग कहते हैं आइजैक न्यूटन, कुछ लोग कहते हैं गॉटफ्रिड लाइबनीज द्वारा, और इसको जो है इन्वेंट करने का पर्पस था, उद्देश्य था कि हम रेट ऑफ चेंज और इन सब चीज़ों को समझ सकें. ठीक है. अब क्या होता है यार कि in high school when we learn calculus we don't really delve deep enough into it. हम बस उसको मतलब ऐसे प्रॉब्लम सॉल्व करना हमको आता है, लेकिन हम ये नहीं समझ पाते कि यार इसका मतलब क्या है. अगर हम लिख रहे हैं इंटीग्रल ऑफ एक्स स्क्वायर, इसका रियल लाइफ में मतलब क्या है, इंटीग्रेशन क्या है, डिफरेंशिएशन क्या है, लिमिट्स क्या है, डेरिवेटिव्स क्या है, इन सब चीज़ों का मतलब क्या है, ये सब हम समझ नहीं पाते हैं. तो एज अ सेड, calculus has two parts. Wait a second, let me change the lighting so it doesn't give me hospital vibes. I think it's better now. Okay. So calculus has two parts. The first one is differentiation. Okay. Is it visible? Yeah, it is. And the second one is called integration. Now, differentiation is the one which is primarily concerned with rates of change and stuff like that, and integration is the one which is the polar opposite of it. Like in differentiation, you are given a function and you need to find its rate of change with respect to something. For example, rate of change of velocity with respect to time, which is acceleration. And in integration, did I say this in context of differentiation? I hope I did. Sometimes I just fumble a lot. Okay. So in integration, you care about the original function which is changing. Like you are given the rate of change and you have to find the function. So if you have velocity, then its integration will be displacement, and if you have, let's say, acceleration, then its integration will be velocity. They are just opposites. Okay. So here we will be focusing on differentiation, and just to let you know, this is going to be more intuitive than theoretical. Like there won't be very much actual math like stuff and more intuition, so that you understand the real meaning of it all. So you all must be aware of velocity, which is change in displacement upon change in time. So this is how we write velocity: change in displacement divided by the change in time. So if we graph it, then this video is gonna be very raw, and I apologize for that. So let's say at time 1 the distance covered is 2, and at time 2 the distance covered is 4. Then this will be the velocity. Okay. Coordinates of this point are 1, 2, and for this it's 2, 4. So now to find this, which is velocity, because velocity is this change in displacement, which will be this 4 minus 2 or 2 minus 2. Sorry, my processing, the processing is quite slow. So it will be 4 minus 2 upon 2 minus 1. So it will be 2, right? And let's say we extend this at time 5. Then this will be wait a second, I'm just getting confused. Okay, so I just got a bit confused. I apologize for that. Okay, maybe I'm very nervous right now, and I'm feeling really quite awkward. That's why I got confused. Okay, so as I said, at time 5, it will be the displacement will be 10, because as you notice, when this is like time, this is displacement. When time is 1, this is 2. When time is 2, displacement is 4. So the graph, the equation of this line is y is equal to 2x. Okay. Or rather, you also write it like fx is equal to 2 times x. Okay. So if you put x is equals to, which is actually t is equals to 5, then this will be 5 to 2 is equal to 10. So if you put 3, then it will be 6. Okay, so this is a linear graph where the velocity is constant. But then comes the graph where the velocity is not constant. Okay. Let's take the equation fx is equal to x square. This is the most common one. Okay. We will have this 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So at x is equal to 1, y is 1. At y is equal to, at x is equal to 2, this y is 4. Okay. At x is equal to 3, this is 9. Right. And at this will at x is equal to 4, this will be 16 y. So this is the sort of graph which it makes. This is not a straight line, clearly. Yeah, this is not a straight line, you can clearly see that. This is a curve. Now the problem with the curve is that the rate of change is not constant. Like if you take the rate of change between this point A, point B, it will be different. If you take the rate of change between point C and point B or point A, these all will be different. Okay, and I'll not go into that because that is very basic and that is not the part of our actual illusion which we are trying to achieve. Okay. Just split a screen. Yeah. So you can see here this is 3,9 at this point this is 1,9. Now 9 minus 4 divided by 3 minus 2. This equals 9 minus 4 1. This equals 5. And here 2 comma 4 upon 4 minus 1 upon 2 minus 1. This equals they're different, they're not the same. And when we do this 9 minus 1 upon 3 minus 1, the result is 4. These all are different. Okay, 5, 3, 4, which means that the velocity is not constant. So then the question is that how do you find the rate of change at a particular point in time? Now this should sound paradoxical to you because change inherently requires two distinct points. If we see that A has changed, you can't say that A has just remained A. A has changed to B. By some factor, it has to change to B. So this sounds quite paradoxical, but it is very, very deep. And here is where we introduce the concept of limits and also infinitesimals, which you probably might not have heard of. Infinitesimals. Just a second. Yeah. So to understand limits, you have to understand the concept of continuity. Now what's continuity? Let's say a car is being accelerated. It is moving with a velocity of 4 km per hour. Okay, this is its speed. Now, if it is being accelerated, then its velocity will keep on changing, like with very extremely tiny, extremely small amounts, like smaller than what you can imagine. You could imagine any small, remember the smallest of the smallest. This will become very clear when we introduce infinitesimals. But does this happen that one moment it is 40 km per hour, and the moment you press the accelerator, it accelerates to, let's say, 45 km per hour? That does not happen. It takes time. Before that, it goes through, like I said, 40.001, and then it continues its journey towards this 45 or whatever. So this is what we call limits. Continuity. This is continuity. Okay. And now here is this graph which we talked about. This curve. Now, if you want to calculate the rate of change at this point in time, you have to calculate. Firstly, you can't calculate the rate of change at a point in a general sense. You could say a more intuitive sense. So, what we do is that as you bring this reference point closer and closer to this original point, which we call A. Okay. The rate of change at this point in time becomes, you could say, it becomes more accurate, more precise. The precision becomes, it escalates. So the concept of limit is that, let's call this point P, the distance between A and B shrinks infinitely. Now what does it mean? Something shrinking, the distance between A and B shrinking infinitely means that this process of the distance reducing never ends. Let me explain this to you more intuitively using a quite famous concept called the Zeno paradox. Now what Zeno says is that, let's say this point A, this point B, the distance is 1 unit. Okay. To travel through 1 unit, you will have to cover half a unit, right? To cover half a unit, you will have to this, right? And then by 8, and by 16, and so on. Okay, so it keeps on increasing, and it keeps on reducing this distance. So this small distances which you have to cover in order to get here at point P, this becomes, this approaches infinity. But the distance is not infinity, it is 1 unit. So this is what the distance shrinking infinitely means. Right? So this is the concept of limits. Another example, we use this in calculus very often. Let's say this is time and velocity graph, velocity time graph. Okay. This is the time. A x1 will be better. x1, x2. Okay. So for this point of time, the velocity is constant because you see the y-axis is not changing. This is y2. Then it suddenly jumps at time x3. The velocity jumps to y3. Okay. This is the same thing as the speed of the car which we discussed earlier, magically turning 45 without going through 40.001 or whatever, or right. So this is this. Now, if you keep refining this, let's say this is x4. Okay, have a step. Now, if you keep refining this, what does that mean? If you keep reducing this whole, like the length, the distance between these points, if you keep reducing it, which means that if you keep reducing the breadth of these rectangles, if you keep refining them, okay, this is clearly not a rectangle, but just for the sake of it, and as you do that, you notice that it approaches a very quite well-known shape, which is this. Although it's not a triangle, but let's just consider it from this point as well. Okay, you see this thing, earlier it was like this, so this space like this, wait. This is disappearing. These triangles, these small triangles, still looks like crap, but still. So in the limit, this disappears, and now we have this continuous one. So I hope you understood limits. Now we shall move to infinitesimals. Now what are infinitesimals? Infinitesimals. Everybody who learns calculus in the 21st century is familiar with these terms: dx, dy, dtx, etc. So this represents dx and dy. These are the infinitesimal forms of delta y, delta x, delta t. Right? These represent the infinitesimally small changes. What does the term infinitesimal means in English or in mathematics? You could say it means something, some quantity which is small, infinitely smaller, which is smaller than any real number which you could think of. So it is called this an infinitesimal. 0.00000. No matter how far you take it, these infinitesimals, these people will always be smaller. Okay. dx, dy, dt. That's why you write dy by dx, which is just this. But these are infinitesimals and these are like jumps, you would say. But the defined quantity is this. I hope you are getting it, okay? You're getting what I'm actually trying to convey and you're not misinterpreting it. You can tell me in the comments if you misinterpreted something or if I apparently said something wrong. I could correct that and I would mention you, okay? So these were infinitesimals. Now, there are orders of infinitesimals like dx square, dy square, dx power 4. अब ये क्या है? See, the reason why dx square and dx power 4, dx dy power 2, these are higher order infinitesimals and not 2dx or dx into 4 or something like that. These are not, or dx plus 1000. These are not higher order infinitesimals. Let's take dx square. What is dx square? Dx times dx. This means infinitely reducing dx by an infinitely small factor. Okay, not reducing but increasing dx by infinitely small factor, which means that you are increasing dx. Multiplication means you are increasing it, like this into 2, this increases it. But if you write this into 1 by 2, you are decreasing it. And if you multiply it by this infinitesimal, which is smaller than any number which you can ever think of, then you are just reducing it. And this itself is an infinitesimal. So dx square, this lies in the set of second order infinitesimals. Okay. Similarly, there is dx cube and dx power 4, and just goes on. What else do we have? So anyways guys, we also have this proof of y dx square upon dx equals 2x. We have a geometric proof of this. Let me demonstrate this to you. Imagine there is this square with sides x, 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 x. Now, this is the length of this side, and the breadth between are increased with an infinitesimal amount dx. Okay, so it's infinitesimal, but just for the sake of so that you can see it, I've drawn it this way. So now we have these things, we have these two rectangles and this tiny square. So the area of this is h dx, and this is also x dx, and this is x dx square. So dA, which is the infinitesimal change in area, right, of this square equals the area of this plus the area of the second rectangle plus the area of the tiny square. Now we can write it as dx square. Okay, this is not dx square. These are not equal. This is d of x square in the parenthesis. And these two things are different, distinct, not the same at all. So this is also x dx, this is also x dx, so this will be 2x dx. And then we have dx square. And we eliminate this. What's the reason that we eliminate this? Because, as I told you earlier, dx square is the second order infinitesimal. Second order infinitesimal. इसका मतलब है कि it is infinitely smaller than dx. So if it's infinitely smaller than dx, then we won't consider it. Similarly, the first order derivative, this is also infinitely smaller than any real number you think of. This 0.001 plus dx. We'll ignore it because the order is different. Okay, just for the sake of interpretation and intuition, you could say that these two lie in different realms of reality, which is not the way they are, but for the sake of intuition and interpretation, you could say that. So that's why we ignore this, we eliminate this, and then we just shift this here. Basic algebra, dx square divided by dx equals 2x square. That's why the derivative of x square is 2x. So this is the proof. So thank you very much for watching my video. This video is gonna be almost raw. There will be very few modifications. If you have any questions regarding this, then you can just comment it down in the comment section, and I will reply it to you. If you think apparently I did something, that I just said something which was inaccurate, then you could or you can point it out and just tell me in the comments. So thank you very much for watching this video. I hope you liked it. Okay, this was my first video, so I was very nervous and a bit awkward, and to be really honest, I didn't feel as if I actually delivered in the way that I was planning to, but still I gave it my best. So thank you very much.